These temperatures are usually recorded to give the operator guidance during startup. You must make sure to learn and remember the limits which are established for each of your turbines. In order to increase the output of the turbine, steam flow is increased, and this consequently adds more heat to the metallic components, causing expansion. The operator must take care not to increase steam flow or steam temperature too rapidly, as this could lead to unequal expansion of components and possible distortion. When this occurs on the rotor, it leads to an increase in eccentricity. The shaft and rotor take on a slight bow due to temperature distortion, and this is exaggerated by the centrifugal force of rotation. Eccentricity is dangerous because it results in a reduction in radial clearance between the rotating and stationary parts. The degree of eccentricity is measured and recorded at the operator's terminal or control board. In most machines, an eccentricity of 5 mil is considered very high. High eccentricity also shows up as an increase in vibration at the bearings. In actual fact, the expansion of the turbine components in the radial direction is quite small. On the other hand, the longitudinal expansion, that is, in the axial direction, is considerable, perhaps 1 to 2 inches between the cold and full load condition. We have already seen how the turbine construction allows for the shell to expand axially, usually on sliding feet at the governor pedestal. Now, while this is happening, the rotor is expanding, but in the opposite direction. Remember, the high-pressure end of the rotor is secured by the thrust bearing. It would be convenient if both the rotor and the shell were to expand at the same rate, but in practice, this does not happen. The reason is that the rotor is considerably lighter than the shell, and therefore it expands more rapidly. So during the initial loading of a cold machine, the rotor expands at a greater rate, and in fact, we run the risk of the rotating blades coming into contact with the next stage of stationary blades. This differential expansion must be kept within certain limits by restricting the rate of change of load on the machine. Differential expansion is measured and indicated at the operator's control panel or console. Typically, during startup, we will observe a positive differential expansion increasing continuously up to about 100 or 150 mil. We may have to restrict loading in order to keep from exceeding this level. Eventually, as the casing expands further and further, the differential will decrease and probably settle down to, say, plus 50 mil. The reverse situation occurs during a shutdown. In this case, the rotor contracts much more rapidly than the shell, and as a consequence will reduce the differential expansion and generally move into the negative zone. Normally, the manufacturer sets limits of differential expansion for both the negative and positive sides. The expansion position of the governor pedestal is also indicated. After a short overnight shutdown, it is probable that the turbine shell will still be considerably expanded, while the rotor has contracted to provide a negative differential. This indicates that a hot start is required.